In figure, an albatross glides at a constant 15 meter per second horizontally above level ground, moving in a vertical plane that contains the sun. It glides towards a wall of height 2 meters, which it will just barely clear. At that time of the day, the angle of the sun relative to the ground is 30 degree. Now, at what speed does the shadow of the albatross move across the level ground and then up the wall? Suppose that later a hawk happens to glide along the same path also at 15 meter per second. You see that when its shadow reaches the wall, the speed of the shadow noticeably increases. Now, is the sun now higher or lower in the sky than when the albatross flew by earlier? And D part, if the speed of the hawk's shadow on the wall is 45 meter per second, what is the angle theta of the sun just then? So here in the question we have this albatross that is moving horizontally and it just barely passes over this wall, and sun rays are coming from this side and it is making an angle theta with horizontal. Now you can see that when this albatross moves, its shadow will form on the ground. This is the shadow that will form on the ground, and as it moves near to the wall, now this shadow reaches here, and as it moves further, so its shadow will move up the wall. So what we have to find out, we have to find the speed of these shadows when the shadow is here and when the shadow is here in this part A and B. Now, in order to answer part A, if you observe carefully that the shadow is forming due to the sun rays, and the sun rays are coming from sun, means the rays are coming from far off, so they are parallel to each other. So the sun rays that are falling on this albatross are parallel to each other, means this angle theta, so this is also angle theta. And let the bird is moving from point A to B, and it is moving with a constant speed 15 meter per second. Now this is the ground, and let this is point B dash, and from this geometry you can clearly see that this A dash B dash will be equal to AB, as the sun rays are coming parallel. So if this is theta, so this will be theta, this is also theta. So the time taken by the bird in moving from A to B is equal to the time taken by the shadow in moving from A dash to B dash. So the answer to the first part is the speed of the shadow. The speed of the shadow on the horizontal ground is 15 meter per second. Now in order to answer the second part, that in which we have to find the speed of the shadow up the wall. Now consider that this is the wall, height h, clear, and the bird is here, say this is the bird, and let at any instant of time it is at a gap x, and let the shadow of the bird is here, and let this is y, and the sun rays are coming this way, and we are given with angle theta here. So if this is theta, so this is also theta. Now from this triangle you can write that y is equal to x tangent theta, and if I differentiate it, so I will get dy by dt is equal to dx by dt into tangent theta. Now this dy by dt is what? The speed of the shadow in this direction, up. The speed of the shadow in this direction means towards this reference point O. So this is the speed of the shadow, clear, and it is equal to Vx, means the speed of the bird towards this point O, and tangent theta. Theta is 30 degree, that is given, so this is 30 degree, and we know that this Vx is 15 and tangent 30 degree is 1 by root 3, so we get 8.7 meter per second. And how we come to know that the shadow is moving towards the point O? So for that, if you look carefully, that this x, as the bird is moving towards this point O, this x is decreasing, so you can put negative sign here as dx is negative. So this is negative, this is negative, and this is negative. This means that as the bird is approaching towards this point O, this distance from this point O is decreasing and the velocity is towards this point O. So negative sign shows that the movement is in this direction, as measurement of h from this point downward is taken as positive. So negative means that the image is approaching towards point O. Clear? Now the C part of the question is for the movement of the hawk, and the hawk is also moving with the same speed of 15 meter per second, but when the hawk reaches the wall, the speed of the shadow noticeably increases. Now from that we have to tell whether the sun is now higher or lower in the sky. So from here you can see that this dy by dt is equal to dx by dt tan theta. Clear? Now this dy by dt is increasing. This part is given that this has increased, and this part is constant. This part is constant because it is 15 meter per second. This means that this tangent theta part has increased, and this part can only increase when theta increases. Clear? So from here we can say that in such a situation theta will be greater than 30 degree definitely, and sun is higher in the sky, and the sun is higher in the sky. Clear? Now in the D part it is being asked that if the speed of the hawk shadow on the wall is 45 meter per second, then what is the angle theta of the sun just then? So from this same result you can write that tangent of theta, that is equal to Vy by Vx, and we know that according to the given value this is 45 meter per second and this Vx is 15 meter per second. So from here we get 3, and solving this we get theta is equal to 72 degree.